In the last video, I introduced you to the Java array. I talked about how to declare an array, how to initialize the elements in an array, and how to access elements in it, using the square brackets and an index. But what actually is an array? An array is a special class in Java. It's still a class. The array, like all other classes, ultimately inherits from java.lang.object. Getting back to the code where I left off in the last video, in the arrays project I created an integer array and set the elements in the array to be the numbers from 5 down to 1. Instead of doing this, I can use a loop to assign all the values with an expression or calculation. First, I'll comment out line 23. Then I'll create an uninitialized array. New array equals new int with 5 in square brackets. I'll run this. Here you can see I get all zeros printed. When you don't use an array initializer statement, all array elements get initialized to the default value for that type. For primitive types, this is 0 for any kind of numeric primitive like int, double or short. For booleans, the default value will be false. And for any class type, the elements will be initialized to null. For my array, an integer array, 0 gets assigned to each element in the array by default, and you can see that here in the output. Now I'll use the basic for loop to assign the values as I had them before in reverse order. And I'll insert that before the loop that prints out the values. The for loop will be the same as the one below. New array I in square brackets equals new array.length minus I. The loop setup is the same as before, but inside the loop you can see I'm assigning each element in the loop. I'm using the square brackets and the loop variable I within the brackets to assign a value to each array element. And it gets assigned whatever the value will be when the current index is subtracted from the length of the array. When this is 0 to start, I get the length of the array as the first value, which is 5. And when I reach the max value, which I've said was 4, the element will get the value 1. Now if I run it, you can see I got the numbers printed from 5 to 1. You can use a loop to populate and initialize elements in an array as I did here. And I've used a traditional for loop to do that, as well as print out the elements. Java has another for statement. They call it the enhanced for loop, but it's also sometimes known as the for each loop. I've mentioned this version of the for loop, and I said I'd talk about it when I got to arrays and collections. Well, here we are. This loop was designed to walk through elements in an array or other collection types. It processes one element at a time, from the first element to the last. Here is the syntax for the two types of for loop statements side by side. The enhanced for loop only has 2 components versus 3 defined in the parentheses after the for keyword. It's important to notice that the separator character between components is a colon and not a semicolon for the enhanced for loop. The first part is a declaration expression which includes the type and a variable name. This is usually a local variable with the same type as an element in the array, and the second component is the array or some other collection variable. Let's see this for loop in action. I will do what the last for loop did in my code, which was to loop through each element in the array and print each value out. But this time, I'll use the for each or enhanced for loop to do it. I'll call println to make some space. For and in parentheses int element colon new array. And print out element using print with a space after it. First, I just print a new line, so with some separation between the output from the 2 for loops. Now I've got the enhanced for loop code. Notice that it looks similar to a traditional for loop, but it uses a colon and not semicolons and expects only 2 components in the parentheses. The first component needs to be a declared variable in the for loop itself. In this case, I'm looping through an array of integers, so I want to set this variable to an int type. And here, rather than just the letter I, I'm purposely using something more descriptive. This is because the variable is the actual element and not the array index I'm looping through. The second part, on the right side of the colon in the parentheses, is the thing I'm looping over. In this case, it's my integer array, new array. And now, in the print statement, I don't have to use an index to get the element from the array. The enhanced for loop gets it for me and stores it in that local variable element. In this case, I don't have to know what the index is at all. If I wanted it or needed it, I'd probably use the traditional for loop. If I run this now, I get the exact same output. The values 5 through 1 are printed out. That's rather a nice thing because we don't have to deal with the array index position. The enhanced for loop gives us a simpler, less error-prone option if all we need to do is process the elements from start to finish and we aren't trying to set, swap or sort elements. Okay, so you might be asking, can't we just print the whole array using system.out.println? I will try that next. I'll add a blank line and print out new array. What happens if I run that? I get this strange thing printed out, and it's not a neatly formatted list of my array elements. Why is that? Well, I have said that our array is really just a special Java class, and this is true if you recall when we attempted to print an object instance out earlier in the course. We got a similar looking set of numbers and letters. That output, and the output we are seeing here, is from the java.lang.objects2 string method. We had to override the toString method to see meaningful output for our classes in previous sections of the course. Unfortunately, we cannot use that approach with arrays. The output, by the way, shows a left square bracket with a capital I, which means it's a primitive integer array, and then it's followed by the hexadecimal representation of the hash code. This is not likely to be very helpful to you as you examine and manipulate your array. While we can't override the toString method on an array, like we could do with a regular class, there is an alternative to get the output we seek. Java provides a helper class that contains a lot of static methods which you can use for arrays. This class is the java.util.arrays class. Java's array type is very basic. It comes with very little built-in functionality. It has a single property or field named length, and it inherits java.util.objects functionality. Java provides a helper class named java.util.arrays, providing the common functionality you'd want for many array operations. These are static methods on arrays. They are class methods, not instance methods. In the next video, I'll be looking at this class in a lot more detail. For now, I'll use one method in this class to print out the elements in my array, and this method is arrays.toString. The toString method in this helper class prints out all the array elements, delimited, and contained in square brackets. The output from this method is shown here conceptually. It prints the element at index 0 first, followed by a comma, then the element at index 1 next, a comma, and so on, until all elements are printed. Let's see what this looks like for my integer array. I'm going to replace that last system.out.println statement in my code with a different one. I'll print the output from arrays.toString, passing new array. And now if I run that, you can see that we get the 5 elements printed out in square brackets and comma delimited. That's a handy method, which may be all you need if you just want your elements printed on a single string this way. One other thing you should know is that you can assign any array to an object variable. Let's look at this more closely. Object variable equals new array. If object variable instance of int square brackets, print the literal string, object variable is really an int array. In this code, I'm assigning an integer array reference to an object reference. And notice here that I can still use the instance of operator using an array type on the right side of the operand. This operand will test if my object variable is really an instance of an integer array. While an array is a special class recognized by Java through the use of the square brackets, it still inherits from the java.lang.object class. You might ask, why would I do something like this? Well, in fact, you could create an array of objects that supports any kind of type in Java. Let's look at that now. Object square brackets object array equals new object with 3 in square brackets. So an array of 3 objects, set element 0 of object array to the string literal hello, set element 1 of object array to a new instance of string builder initialized with a string literal world. In this code, I'm creating an array of objects, and this array will hold 3 object references. And now I can assign any object reference of any type to the elements in this array. First, I assign it a string literal, and then I assign it a string builder instance. You could assign an object of any of your own classes to this kind of array. This is one way of having an array of many different types. I'm not saying this is good practice, but I did want to point out that you could do this with arrays. Later, you'll learn more elegant ways to support different types in arrays. And because I know an array is an object, I can assign an array to be an element of this type of object array. Set element 2 of object array to new array, I've got an array of objects, and one of the elements is an array of integers. This is a nested array. I'll be looking at this in more detail when I talk about multidimensional arrays. But what's important for you to understand right now is that an array can be treated like any other object instance in Java. So those are the basics for the array. In the next video, I'm going to discuss the java.util.arrays class in more detail. This is a helper class you'll want to get to know better because it has a lot of functionality for array manipulation, saving us from having to write the code ourselves. I will see you in that next video.